This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. I see this, and the first question that I ask myself is there anything that I can strip from this as n becomes really, really large? Like, what becomes insignificant? Well, the ones would become insignificant. So if I know I can strip something, that's a good indication that I can use direct comparison test or the limit comparison test. Because for comparison tests, you need a sequence to compare to, and you get that by stripping things that become insignificant when n gets infinitely large. So if you see that you can do that, try one of them. I always try the direct comparison test first. So I first write the rule. So remember that this is our A of n. That's our given sequence. So we start with A of n less than or equal to B of n. And what's going to determine if my series A of n converges or diverges is going to be the behavior of the sum of B of n. So if the series B of n converges, then my series A of n will converge. And then I just take the opposites of these. This becomes greater than or equal to, this becomes diverges, this becomes diverges, and then everything else just drops down. Now DCT is I, B, B, C, C. So I stands for the information that we know versus the information that we want. The information that we know is that A of n is equal to our sequence that's given here. The information that we want is our B of n. We want to know what our B of n is because we need a B of n. We need another sequence to compare to for comparison tests, for direct comparison and limit comparison. So that's where the B comes in, which is, hey, find your B of n. How do you do that? Well, you say at large n, so as n gets infinitely large, then you take your sequence of n, you just drop it down, and you ask yourself, it becomes what? Well, as n gets infinitely large, what becomes insignificant? Ones, because what is a minus 1 and a plus 1 going to do? So you can strip those away, and you're just left with n to the 1/3 over n squared. And that is your B of n, but you can simplify that. So this is really 1/3 minus 2. So you could do 3, 1 minus 6, that's going to be negative 5/3. So that just means 1 over n to the 5/3. So now you have your A of n and your B of n. So then your third step is to find out how the series of B of n behaves, because you want to know if it converges or diverges. So all you do is you say series, and then if you see n is equal to 1 here, you're going to put that there. If you see infinity here, you're going to put that there. And then you take your B of n, which is this, and you're either going to use a p-test or geometric test. This is already in the form of 1 over n to the p, where p is equal to 5/3. And so the way that I remember my p-test is the PG-13 rating for the movies. So you do p is greater than 1, and the 3, I think of it as like a sideways C, so it stands for converges. And then the opposite is true, less than or equal to 1 diverges. And since p is equal to 5/3, if you have no number sense, you can literally just divide 5 by 3. It goes into at least one time. We don't have to finish because now I know that if it goes into at least one time, it's going to be greater than 1. So therefore, this series B of n converges. So now we know the behavior of the series B of n. We know that it converges. So we're done with this step, and now the next step is to compare A of n and B of n. And you hope that A of n is less than B of n, because if this is true, and you already know that this is true, then we can say that our original series of A of n will converge as well. So you just do what it says. You take your A of n, drop it down here. You take your B of n, drop it down here. You put a circle in between. But here's why you might not want to use a simplified version of B of n, because it's not very clear which one's bigger here. But we know that B of n is also this. We just simplified it to that. So how about we just take this, put it here, just use the simplified version of B of n when we're trying to actually find how does a series B of n behave, and use the unsimplified version to compare. And also remember that direct comparison test can only be used on series that are only positive, so the terms can never be more than 0. So then here's how I do this. I see the same thing over here, same thing over here. But here, that same thing has one more to it, making this bigger than this one. And then here I see the same thing, but over here it's the same thing minus 1. So this is smaller than this. So let's say this is smaller, right? This is 4, and maybe this is 8, and then this is bigger, so let's say it's 8 and this is 4. Because these two things are always true, then what's going to happen? Well, this becomes 2 over 4, which is just 1/2, and this becomes 2. So the smaller one is this one right over here. This will always be smaller because it will always have something that's smaller divided by a bigger thing. And now you have that your sequence A of n is less than or equal to your sequence B of n. That's this one right here. And now because we have this is true and this is true, then therefore we can say that our given series A of n n converges. So then we get to our conclusion part, and I always start with since, and then I just copy my work. I already wrote this. So since the series converges by the p-test, and step 4, my sequence A of n is less than or equal to my sequence B of n, but they're all greater than 0. So in other words, I'm just saying because this and this are true, then the direct comparison test implies that my series A of n converges. And to be more specific, you could say for n greater than or equal to whatever number you have here, which is 1. So this is true for all n is greater than or equal to 1. And that's our conclusion. I'll see you in the next video.